Good day, everybody, and welcome back to day 2 of Shaping the Future of Radiological Protection, Engaging the Next Generation. Again, I'd like to thank the speakers that came by yesterday to share their stories about why and they joined RP and some of the experiences that they've had because of it. Day 2, as we talked about a bit yesterday, is kind of more of the look at engaging the next generation through an organizational lens rather than kind of on a first person perspective. So we've got a great list of speakers today. I'm not going to take up too much of your time. I think I spoke enough yesterday. So after the speakers are done, again, please say or feel free to put in questions into the Q&A box below. You can ask them at any time. We won't get to them probably until the end of the speakers, and then we'll have a bit of a panel discussion and a quick wrap up. So enjoy today. Thank you for coming. And I will start by introducing the moderator for today. Lorenzo Mazzoni is a medical physics and radiation protection expert working at the Medical and Health Physics Unit of the Italian Health Authority in Tuscany. And he is a council member of the European Federation of Organizations for Medical Physics, EFOMP. He's a member of their International Affairs Committee. He's also the main representative for EFOMP 2 ICRP and a member of ICRP Task Group 127. So thank you, Lorenzo, for agreeing to do this today. Welcome, and the floor is yours.
Thank you very much, Kelsey, for the introduction. I share my screen. You should see my presentation.
Yep, looks great.
Great. We did it. Well, thank you very much, Kelsey. It is a real pleasure for me to be here opening this second day of this important webinar. We will have several outstanding speakers during this webinar, so please let me thank all of them in advance for their participation. I wish to thank all the sponsors and all of you that are here. We are going to talk about a topic that is very important for me also from a personal point of view, that is the shortage, the decline in interest that we are experiencing in many different fields of radiological protection. That is something that we have to face in the coming years. And so we will have, at the end of the webinar, we will have time for a Q&A session. So I invite all of you to take an active position. Please use the chat, use the Q&A tab, write comments, ideas, questions, whatever you want. So because we will be happy to use all this feedback during the Q&A session. Okay. I start with a quick introduction on why a unified effort dedicated to stop this decline in interest in radiological protection is essential, why this should be our priority in the coming years. And to do that, I start with a short introduction on what is happening in our societies with regard to ionizing radiations. For example, in medicine, we are seeing an increasing number of medical exposures and novel practices involving ionizing radiation. And that's good because this probably means that we are providing a higher level of healthcare service to the people, but clearly we have to manage these novel exposures. In the energy sector, we have about 65 reactors currently under construction and about 90 that are planned to be built. I think that Bryant will go through this point in more details during his talk. There are several industrial and agricultural applications involving ionizing radiations. And there's a need for preparedness and response to nuclear and radiological accidents. We hope not, but this is something that society needs. There are the space travels. So I think that we can say that societies are needing to use ionizing radiations in several different fields and the whole world. I think that we can say that there's a need to use ionizing radiation for different purposes through reasonable choices and transparent and shared decisions to promote well-being of people, to promote society's development in a safe and effective way. Okay, but what is going wrong now? Well, I show you now a few examples of articles dealing with the shortage of radiological protection professionals that we are currently experiencing in many different fields. Here, for example, we have Physics Today that in 2023 published an article entitled "Alarm Sounded Over Declining US Radiation Professional Workforce." The Bulletin of the Atomic Scientist, Nuclear Safety Staffing in the United States, a crisis with no easy fix. Here we have a similar article from the UK that starts with the following sentence: it is evident that there is a nuclear skills shortage within the UK. And here we have the NCRP, National Crisis. Where are the radiation professionals? And last but not least, a data from my country, from Italy, where in 2024, only 18% of the residency positions opened in radiation oncology were assigned. And consider that till, I think, 10 to 15 years ago, we have very long queues of students willing to enter these positions that are no more appealing. So this is a crisis, and this is the scenario. And given this scenario, ICRP decided in 2023 to take an important position and published the Vancouver Call for Action to strengthen the expertise in radiological protection worldwide. So ICRP calls the whole world to do something, to take concrete actions to stop this situation. And I really thank the ICRP for doing this, because in principle, in my opinion, they could have, I don't know, ignored the problem, because in principle, they could keep on providing very important, very valuable recommendation without going too much into their applications. Instead, they decided to say, no, this is a very, very big problem that we have to face. This is probably the most important issue that we see for the harmonious development of the system of radiological protection. So we have to do something, and we have to do something all together. This is what they say. I report here an excerpt from the Vancouver Call for Action, where it is reported that a shortage of investment in training, education, research, and infrastructure seen in many sectors and countries may compromise society's ability to properly manage radiation risks. Okay, so going back to what I showed you in one of the previous slides, this is what societies are asking to all of us. This is what societies need, but without resources, without professionals, without people involved in, the risk is that any recommendation, any good idea will remain just ink on paper. And this is what we have to avoid. Okay, why this happened? Well, I do not have a comprehensive answer. I have an opinion. I show you here what ICRP published, again in the Vancouver Call, about this. The resource limitations may be related to a variety of factors, including national policies. a mistaken perception that everything is under control and no work is needed, or due to the underestimation or lack of knowledge that overall that the beneficial use of ionizing radiation plays in many sectors of science and society today. I personally share this analysis, and I wish to add also a personal opinion that for many years, for a large part of the population, the word nuclear has been perceived as a bad word. And whatever is the opinion that legitimately every one of us can have about the use of nuclear energy, well, this probably damaged also the radiological protection sector. This is my personal opinion. Okay, following the Vancouver call for action, several regional and international organizations shared the danger posed by a declining interest in radiological protection, embraced the Vancouver call, and agreed to support ICRP initiative to strengthen the expertise in radiological protection. Here you can see the list of organizations that came together with one voice to say that strengthening the expertise in radiological protection is a collective priority for our community. And to me, this is a very, very important step forward because those organizations represent the vast majority of the radiological protection community worldwide. And as far as I know, this is the first time that they come together with one voice to say that we need a stronger radiological protection system, that we have to stop this declining interest in radiological protection. Here you can see the paper that the representatives of this organization published in support of the Vancouver call. And I think that this paper, together with the Vancouver call, can represent a valid tool, an important tool to support policies dedicated to strengthen the expertise in radiological protection. So please, I invite all of you to go to the website, download the papers, okay, and use those papers to foster this kind of policies also at the local and the national level. This is something that I think we should do in the coming years. Okay, given this scenario, now let's see what is needed. This is something that we will see in more details in the coming talks, but I just want to show you what ICRP published. This is the ICRP's big picture about what is needed. We need national governments strengthening resources for radiological protection research. We need institutions launching and sustaining long-term research programs. We need university developing undergraduate and graduate university programs and making students aware of job opportunities in radiation-related fields. We have to use plain language when interacting with the public. Yesterday, many speakers talked about this. Communication is a very, very important point for us. We have to engage the public to make people more familiar with what we do during our job. And we have, in general, to foster awareness of proper uses of radiation. Okay, after the big ICRP picture, let's go to what is needed from my personal small picture. Okay, this is my small picture, personal opinion about this. And for sure, we have to reinforce a system of competencies and skills. So we need high-level education and training. We have to make radiological science and related professions more appealing. And I think that probably here we have also to talk about salaries. Maybe we have to pay people more. But in general, we need political actions at all the levels. And to do all these things, I think that we need a community. And this is something that is particularly important for me because I like communities very much. And when I was preparing this presentation, I reflected pretty much on what we need to build a valuable community. And I think that we need two things. We need shared values and shared objectives. And I think that we are lucky because we have both. And thanks to the ICRP, we have also the group of organizations that are in formal relation with ICRP that can act as a group when they have shared positions, as they did in support of the Vancouver Call. And this group of organizations can represent the backbone of this community. So we have to encourage dialogue and communication also among us. That's why we are here. Again, please use the chat. We need enthusiastic people because there is a lot of work to do. There are so many open possibilities with so many different careers yesterday. So please share this position, this optimistic position. We need money, and specifically, there is a donation program linked to this webinar. All the money that will be collected will be used to facilitate the participation of early careers and students at the next ICRP symposium in Abu Dhabi. So please donate, donate, donate. I really want to thank all the sponsors and all of you who have donated, because those money will be spent for a very, very important reason. The donation program do not stop today, so please share this information also with other organizations that could be interested in joining this donation program in the coming weeks. And finally, last but not least, we need ideas. So again, take an active position, use the chat, write comments, complaints, whatever you want, and finally, air your views. So, thank you very much. I finished my introduction, and now let's start. Let's go to the hot part of the webinar. Let's start with the first session entitled Organizational Initiatives, What's Being Done Today. It is my pleasure to introduce the first speaker, that is Josip Zik. Josip Zik is the Chief Nuclear Officer at McMaster University in Canada. He is also member of Task Group 129. It is a real pleasure for me to have Josip here. So please, Josip, the floor is yours.
Thank you, Lorenzo. For myself, just to introduce myself, I'm Josip Zik. I'm the Chief Nuclear Officer at McMaster University. I'm also the Vice Chair of the World Nuclear Association Radiation Protection Working Group, and I'm going to be talking about some of the activities ultimately from an academic perspective, but also from some of the activities that we're doing in the Radiation Protection Working Group with the World Nuclear Association. And I guess personally for myself, I was fortunate to go to university that McMaster at the time that had a reactor on it. I have to say, like many people, I got into radiation safety not necessarily when I entered university, did I think this is where I was going to end up? But being at a university that had such a big nuclear program, it got me interested and eventually attracted me to this field. And I'll talk a little bit more about that as I go through this presentation and how we use similar approaches for other students today. And so just a little bit about McMaster. We are Canada's nuclear university. So the reactor itself, built in 1959, it's about 65 years old, which would usually mean retirement in Canada. But I have to say that with the amount of work we have going on, the reactor is really working harder, and looking at more areas than it ever has before. And we've actually received funding to expand it even further, build new beam lines and halls. And so a really exciting place to be from a nuclear perspective, but also especially from a radiation safety perspective. Having said that, a lot of people, when they do think of McMaster University, think of the reactor, but we actually have 1,200 people that work with radioactive material, and only about 100 are at the reactor itself. And so we also have a Center for Advanced Nuclear Systems where that was designed to take pressure tubes from reactors and bring them into hot cells and do analysis on them. We have an accelerator laboratory, a high-level laboratory facility, and a cyclotron facility with a 16.5 MeV cyclotron. And the great thing about all of these facilities being on campus is that it allows us to give students an opportunity to not just learn theory, but actually put that theory into practice. From a radiation safety perspective, that is really woven into all of the courses that we teach, because in order for them to go and actually handle radioactive material and work through these facilities, they have to go through radiation safety training and actually be able to measure radiological hazards and really get introduced to the field and why it's important. And so from a research and education perspective, because of our facilities, we've been able to have and maintain a pretty strong health physics training program that works both at the undergraduate and the graduate level. We also try to hire as many students as we can for our nuclear facilities. Can't hire them all, but hire quite a few students as well. And so we have about 40 students that are working in our nuclear facilities. And out of those 40 students, about 14 of them are in health physics specifically. And so again, just a really great opportunities to introduce students to the field, give them a chance to make a little bit of money, but more importantly, give them a chance to see what it actually means to work in this field and see what it's like to actually implement radiation safety programs and deal with really unique and challenging research projects where we have to, change the way that we approach radiation safety. So what I want to talk about today is just 5 things that we're doing. One of them is around outreach. One of them is around formal education, experiential learning, engaging in professional societies, and then transfer and continuing education. So starting with outreach, we do our best to really introduce people just to the idea of nuclear and nuclear technologies. There's not many nuclear reactors around the world, or even research reactors around the world, where members of the public can come into the reactor itself. We've managed to keep our experimental floor clean, so people can actually come in and stand right on top of the pool with the core under their feet and look at an operating nuclear reactor. And so again, just, people are afraid of what they don't know. It's hard to understand something until you can really see it. So being able to open the doors, get people in there, teach them about what we're doing and why it's important to them has received a lot of really good feedback. And we do that starting at a very young age as well. So we have programs for kindergarten, we have programs for elementary school, for high school. So, do everything we can to really teach people about nuclear and specifically radiation safety associated with our nuclear activities. From an education perspective, we have an undergraduate program, which again, very similar probably among many universities, so I won't spend too much time on it, but again, just trying to get students interested in this field. I teach an undergraduate course in health physics, and usually when I start my course, I ask the students why they're there. And out of the students that are there, typically it's going to, about half of them say the only reason that they're there is because it was the only program that fit their schedule. And they think that I take that personally, but I tell them that the real reason we have this course is actually to attract those students. Although I appreciate the students that have to be there because the course is part of their program, it's the students that don't necessarily have to be there because of their program that I'm really interested in. And what we found is that we've had students from chemistry, life sciences, biology, engineering, have taken the course, have enjoyed it so much that they've changed their goals and started getting into nuclear and radiation safety. Similar goes for graduate programs. We have a pretty strong health physics program where a lot of the health physicists working in Canada have come out of our programs, and a lot of that has to do with experiential learning. When you get a graduate course that doesn't just teach theory but teaches people the actual practice, it's a really great way for people to not only understand it well, but also for organizations when they hire somebody, they're getting somebody that has actually done the work, has gotten security clearance, has actually measured radiological hazards, has helped with putting regulatory responses together. It just makes them much stronger candidates. For the UNINI program, it's a program that ties a bunch of universities in Canada together to teach nuclear technologies. Radiation safety is a part of that. I actually had a student a couple of years now that we do remote learning that was on an oil rig in Saudi Arabia working and taking this program, decided after taking the radiation safety program that they liked it so much that now they're working as a health physicist at our national lab. So again, just such a great way to reach out and teach people about what we do and why it's important. We also have international collaborations. So we're collaborating with the University of Alabama at Birmingham, ultimately looking at ways to capitalize on their health physics students. They have a great health physics program, but they don't have as many opportunities to get that hands-on learning experience, whereas we do. And so we're collaborating in a way that we can use some of their remote education, and they can actually send their students to McMaster to get that hands-on learning at our nuclear facilities. We're also developing an international radiation safety standards course. It's starting with just Canada and the US, but hoping to expand further than that, that could give people education in radiation safety standards and how they change around the world. So again, experiential learning, I won't get into too much detail, but for all of our students, what we want is we want them to have projects that really change the way that we do business, particularly with some of the institutions that we work with. And so in this example, we had a student project that developed a type A package that could be used in drone delivery. So we could actually deliver nuclear medicine or isotopes. We could deliver it from the manufacturer processing facility directly to a hospital using a type A package in a drone. And it was students that went through all of the work to get that package certified. So again, experiential learning, I won't spend too much time, but just a lot of opportunities for students to receive training and actually implement that training in the reactor, in nuclear technologies when it comes to techniques for analysis or advanced accelerator techniques as well. And then looking at also collaborations worldwide with different organizations on other nuclear technologies, but always including a radiation safety and health physics portion in that. We also stress the importance of engaging in professional societies and start that early with students. So we support reduced student membership in radiation protection in Canada. So students pay a much lower rate to be part of the society. We do our best from a university perspective to educate students on the importance of being part of these societies and the influence that they have nationally and globally. We also act as an examination site for professional designations. So the Canadian Radiation Protection Association has a professional designation, and so does the American Board of Health Physics. And we just to make it easier for people to write these exams, we make that available at our facility. I also want to mention the Radiation Protection Working Group and the work that we do overall, just to make sure that we can give the industry's voice to different work that's happening around the world, particularly with the change and the revision of the ICRP recommendations. And so it lets us channel that global industry voice. And again, trying to get people interested in this work, especially young people. And so we have engaging the next generation of radiation protection professionals as part of our strategic plan, and have been including that as a focus area for this group. Also looking at transfer and continuing education. So we have, McMaster has a health physics micro-credential program. So what it allows is for professionals that are currently working to be able to take a series of courses. And if you take the whole series of courses, then you can put that together and get a master's in health physics. And so it's been great not only for people that are already working as health physicists, but other people that have similar kind of safety knowledge, but not necessarily the health physics portion. And it allows them to package that in a way that they can support and become health physicists. And then lastly, I'll just mention the World Nuclear University Summer Institute. This is done through the World Nuclear Association, a really great program focused on leadership. But more importantly, as part of that, we do include sessions on radiation safety fundamentals, right? And then how to put radiation safety into practice, have breakout session for teams to tackle radiation safety challenges and just introduce them to the field and let them know from a leadership perspective what they need to know when it comes to radiation safety. And with that, I will close there and be interested in the questions that you have at the end of the session. Thank you.
Thank you very much, Josip, for your very interesting presentation. We have seen several interesting insights, and I like pretty much also when you said that we have to open the door, that people fear what they do not know. I pretty share this observation. I think that this point is very, very important. And so let's go to the next speaker, that is Achim Neuhäuser. Achim is the chief of the staff of the German Federal Office of Radiation Protection, has a background in political science and live in Berlin and love it there. So please, Achim, the floor is yours.
Yeah, hi, I'm Achim from Germany, from the Federal Office for Radiation Protection. I'm chief of staff here. And yeah, I called my presentation The Future of Radiation Protection, which is what everybody is talking about, I think. But yeah, I'm trying to give the German perspective on this. Next slide, please. We'll start with where are we right now in Germany. Next slide, please. Because, of course, it's special for us that we ended the nuclear energy generation about 2 years ago in April 2023, after, I think, about 20 years of discussing, are we phasing out or are we not? And then finally we did it. And I think that's not the end of the political discussion here in Germany, because we are now facing the next government, which is forming right now, and there are strong voices that want to go back to nuclear energy generation. But we don't know. So the status quo is what we see right here. We ended this. And next slide, please. This is, of course, something that affects radiation protection, because we have a decline in the area of maintaining expertise in radiation protection in Germany, as is the case, I think, for internationally. Please press again so that you can see more text. Yes. So I think the importance of radiation protection is not sufficiently recognized by decision makers and the public. This trend is reinforced by nuclear phase-out. We see closure of research facilities. We see difficulties in finding qualified researchers, the reduction of research funding. And this trend is reinforced by general shortage of skilled workers, which is not specific for radiation protection, but adds up to our problems. At the same time, we have constantly new research questions, topics, and fields of application. So we need broad-based skills in research, industry, and government. And next slide, please. This is why there are national recommendations. There's a lot of papers which say, yeah, we have a problem and we need to deal with it. And I think lots of the other speakers have referred to the Vancouver Call for Action. So this is basically something that we have done for Germany as well. And next slide, please. You can see that there are some similar retractions from that. So we need networking, we need involvement of policy at federal and state level, long-term maintaining of research infrastructure, knowledge transfer, and communication. So this is the analysis, but now we see what are we doing right now to improve the situation on the next slide. And I'm just giving some examples. If you go to the next slide, please. So we have 4 pillars, basically: the cooperation and networking, stakeholder engagement, funding and programs, and communication. And then just walk you through these. Next slide, please. So cooperation and networking. I'm just giving an example. I think some of you or all of you met Emily yesterday. She's working with us at BFS, and she has been initiating this European network for early career researchers, and I think that's a great thing to do. So there's a direct reference to the Vancouver Call for Action, and they are doing networking, mentoring, career development for ECRs, which we are supporting by a European research partnership, which is Pianoforte. I will be coming to that project in a moment. There have been some events, and there will be a next meeting in London in October 2025. So if you're interested in joining, just refer to Emily. I put her contact on the slide. Next slide, please. When we go to funding, there are some initiatives which I will point you at. So we have the Pianoforte partnership, which is a big research partnership for the European radiation protection community. And the Pianoforte project is funding a PhD call right now. So there are currently 27 proposals under evaluation, and 8 PhD student positions are to be funded. And there may be another call in 26 or 27, so check the website if you're interested. There are also mobility grants and training courses. So yeah, if you're interested, we'll visit the website. Next slide, please. Here at BFS in Germany, we have a PhD and postdoc program. So currently we have 8 PhD candidates and 4 postdocs working here. Emily is one of them. You can see Patricia. So they are talking about the work on LinkedIn. And we're trying to announce at least 2 new doctoral positions each year because, of course, this is subject to available financial resources. Our doctoral candidates and postdocs can utilize the entire BFS infrastructure, of course. And if you're interested, monitor our job alerts. I put the link on the slide. Next slide, please. And there are so many more possibilities for early and young career researchers. We have the European research platforms, and I gave you an example of 5 of them. They all have young scientists, programs, and support initiatives. So look at the websites. And additional opportunities from the European Commission. There is the NN2+ program and the Marie Skłodowska-Curie Action, which is a fellowship program. They have doctoral networks, co-fund, and what have you. So there's some few examples, and maybe something is interesting for you. Next slide, please. What is even more important for me is the stakeholder engagement. We have to talk to people. We have to do events. We have to publish position papers, engage with national and international politicians to spread the word about radiation protection. We did one big conference in 21. This is something that we do regularly. But it has to be stressed that radiation protection is not only the other side of nuclear power generation, but it's also a really big issue in other aspects as well, talking about technical development, medicine, what have you there. So what we're trying to do is to go to the European level. So we're having a conference on June 3rd in Brussels, in the Pianoforte background. So if you're interested, look at the website and register for this event. We're trying to talk about the necessity for radiation protection to reach the European, the goals of the European Union there. So that should be interesting, I hope. Next slide, please. Of course, there's something that you can do as well. So the visibility of your research is key for relevance. So we all have to learn to and talk about our work because it is part of the job. It's not only that you talk to your peers about what you're doing, but do also talk to the public. Maybe you develop a social media strategy to explain your research. So I have two examples for you. We, as BFS, we did a campaign to gain public interest in the UV protection area, which is not part of ICRP, but which is part of our task. So we used the European Football Championship in 2024, which was taking place in Germany, to gain public interest, and had some sunscreen for free given out near the stadiums where the football matches took place. That gave us some visibility. And we have developed a social media program, an influencer program for colleagues of ours who are talking about their research on our social media channels. By the way, if you're interested, you can follow us, of course, on YouTube, LinkedIn, and Instagram. And so what do we do now? Next slide, please. How do we move on? Next slide. We have established, or we are establishing right now, a radiation protection qualification network under the umbrella of the Federal Ministry for the Environment. Colleagues of ours are establishing a similar network for nuclear safety qualifications. The next slide. They are trying to connect stakeholders for knowledge transfer, recruiting young talents and qualifications. And all the participants in the network aim to contribute to ensuring that there are enough and sufficiently qualified employees in radiation protection in Germany. And so far we have about 60 or 70 institutions being part of this network. So that's for a start. So I think there's a big interest, and we're really trying to move on from there. By the way, this is headed by Werner Rühm, who some of you maybe know as ICRP chairman because he's a colleague of ours here. And last slide, please. So what we also have to do, as I said, is to engage with the stakeholders. We have a new German government coming up in a few weeks. So we have to talk to them, of course. And there is already a new European Commission in place. And we are talking, and we have to talk about funding to them as well. And that's not the only thing that we can do, but that maybe other institutions should join us. And we are trying to use Piano Forte as a platform there to really achieve something for radiation protection. So this is what I wanted to tell you today, and thanks for listening.
Thank you very much, Achim. I really want to thank all the speakers because all the presentation are really fit for purposes. So they really fit with this webinar. They are important because they open several, they explain several possibilities and open other questions. For example, I have one for you, but Achim, I just tell you, but you will answer later if you wish, because you were talking about the fact that Germany switched off nuclear reactors a few years ago. And I would like to have your opinion later about if this affected radiological protection shortage of professionals also in the other fields of application of ionizing radiation, or if you think that this did not happen. And so let's go to the next speaker, that is Jasminka Joksic from IAEA, so a very outstanding point of view. Jasminka is a Radiation Safety and Monitor Program Officer in the Radiation Safety and Monitor section of the Division of Radiation Transport and Waste Safety at the IAEA. So please, Jasminka, the floor is yours.
Thank you very much, Lorenzo. Dear colleagues, I will start with my presentation, and I think that this presentation actually will give you the answers from the Lorenzo's introduction, because International Atomic Energy Agency is will answer at the last 2 points of the Vancouver call for actions, because it is applicable to us as international organization. And I will present you actually 4 modalities how IAEA actually supported the growth of radiological protection workflows. Actually, first 2 modalities are recently launched, while third and fourth modalities are traditional IAEA modalities for supporting young radiological protection scientists. Please, next slide. I will start with our program, Maria Sklodowska-Curie Fellowship Program. As maybe a lot of you hear about this initiative, we started this in 2020. And actually, this program provides young professionals in the opportunity that they have programs in world-renowned accredited universities. And through these programs, agency also support these young women, young professionals with some also funds. Next slide, please. Which is not their salaries, but actually it is some support to pay their basic fellowship needs. There are different fields of the study in the framework of Maria Sklodowska-Curie program. You will see from nuclear science and application, nuclear safety and security, nuclear energy, and also non-proliferation. And this program, with this program, actually, we have to collaborate with a lot of universities worldwide to find a host institute to conduct this program. Also with IAEA collaboration centers that we established with different member states. Also, there are many of other partner institutions, such as private companies in the field of radiation protection and the safety. Next slide, please. This slide is important because it gives you actually a view about the distribution and impact concerning, let's say, geographical how many students actually we will support in different regions, because you know that agency working with all 4 regions worldwide. It is Europe, it is Asia and Pacific, it is Africa, it is Latin America and Caribbean, and you will see from this slide that majority of the students that get this kind of support are from the Asia and Pacific and for Africa. Also, you can compare a number of the students that get support so far in the different field of study, and you will see that nuclear application and science are that nuclear application and science are actually the area in which most students get this kind of support. Next slide, please. I would like to tell you that this Maria Sklodowska-Curie fellowship is a little bit different of Lisa Meitner program. Maria Sklodowska-Curie fellowship we started in 2020, And as you saw, it is a different program that we send our those young professionals to different institutions. But Lisa Meitner program that is released a little bit later actually also provides network opportunities for women in the nuclear field to get even more specific, let's say, on-job training. Through this program, actually, these young scientists visited really a wide range of facilities concerning the nuclear application and standards, and get real practical training. For this, of course, it is important to find some host institution in which this program will be developed. Next slide, please. But also another difference between these two programs is that through Lisa Meitner program, it is not that those young scientists will get only, let's say, scientific and technical skills improved and get knowledge in this field. This program will help them also to develop their managerial and leadership skills. This program includes a lot of on-site lectures and discussion, also training and project development, implementation, laboratory analysis, and also simulation using some advanced computer codes on simulators. Next, please. Why all these initiatives important? Again, Lorenzo also give us some background for the intention to publishing ICRP Vancouver call for actions. So you can also see that agency mandate, according to the statute, is to accelerate and also enlarge peaceful use of nuclear energy. As it was also mentioned, we are now facing a lot of challenges concerning energy, climate change, and so on. So for the efficient delivery of the agency mandate, we really need some stable pool of radiation protection professionals in order to deliver good results. And it is the reason why we developed these two modalities apart from our two traditional modalities in which we support young scientists. Next slide, please. I would like to give the special thanks to the following donors and partners that actually allowed IAEA to conduct these two programs that we recently launched. On this slide, you can see a number of the member states that actually support us by extra budgetary funds, and also some international organization. Because all costs of the Maria Sklodowska-Curie program and also Lisa Meitner are secured by extra budgetary resource, and then we use these resources, of course, in line with agency established procedures. Next slide, please. This is one of our traditional support to the young professionals worldwide in all 4 regions in which agency conducted its program. Actually, we are supporting interns to come that are usually sometimes, before finishing bachelor studies, but sometimes those students are students that just finish their bachelor degrees, and then they have possibilities to be in the agency and work with us between 3 months and 1 year. And I will tell you that that in this process, this is the 2-direction process. Interns benefit to working in the IAEA and introduce them with the IAEA program, while also agency benefit to have a help and assistant of qualified young professionals in delivering the program. Again, This program is also support financially those interns. It is not the salary for the interns, but it is some, let's say, support to cover some basic expenses while they are working in Vienna. Next slide, please. And the fourth way of supporting young professionals is to implement activities through technical cooperation program, through our scientific fellowship and scientific visit that are awarded to the young professionals. Next slide, please. There is difference between these two modalities. For fellowship, we usually support under already established TC project, young scientists to go to some from one country to another, let's say more developed country under the TC program, and to spend up to 1 month usually on some on-job training. There are, of course, some conditions under which we are sending them, and they are also really different type of fellowships depending of the purpose of such fellowship, like on-job training, practical training, long-term academic training, and so on. Next slide, please. Scientific visits are the modality through which, let's say, maybe more senior professionals, sometimes even from managerial levels, go again to another more advanced country to get through the 2 weeks visit, more understand, more knowledge and advices how to broaden their scientific and managerial qualification. And again, there are some selection criteria under which we are conducted the scientific visit. Next slide, please. At the end, I actually would like to finish this presentation with a few slides from my personal experience as being supervisor of 2 interns. One of them is Miss Susanna Velosa Avad. She came to the agency from the Columbia, and she worked with me. After she finished her career internship in the agency, she applied for Maria Sklodowska-Curie fellowship. She got it. She was one of elected candidates with really, I don't know, more than 2,000 applicants. And this program helps her to pursue her professional career in as a medical physicist, first in the Germany, then in the cancer clinic of Montpellier. And actually yesterday, I got invitation from her to attend virtually. She will be defending her master degrees. So it will be my pleasure in April to be on this important event for her. And next slide, please. And my second intern I work with also have a background as a medical physicist. She's coming from Mexico, and she actually passed Maria Sklodowska-Curie fellowship before she joined internship in the agency. Currently, she's working in the hospital in the Mexico. And both of them actually were, you can see from their quotes, so satisfied with all this program. And actually it allowed them, you see, to pursue their career without any break, and really help them to shape their further professional development. Thank you very much. With this, I would like to finish my presentation.
Thank you very much, Jasminka. Thank you for being here. it is fundamental to the efforts done by the agency are fundamental to support the strengthening of radiological protection expertise worldwide. And it is so good to hear that you are doing so much. So I hope and that this webinar could be useful also to share the information about the openings related to the IAEA efforts. Let's go so to the next speaker, that is Hua Li. Hua Li is a senior researcher at the China Institute for Radiation Protection and chairs of the IAT Committee of the China Society of Radiation Protection. Despite his young age, he holds a very long experience in radiological protection. So we are very happy to have you here. Thank you very much for joining us. And please, Hua, the floor is yours.
Okay, thank you. Thank you for your introduction. Hello, everyone. It's great to have this opportunity to introduce China's good practice in getting young people involved into RP roles. So today, my presentation includes 3 parts. So first is a brief introduction about CSRP and its Young's Committee. China Society of Radiation Protection, CSRP, was founded in 1980, and it's the only national academic organization in China focusing on radiation protection. It is also a member of the International Radiation Protection Association, EUTERP. In 2014, with the approval of the Ministry of Civil Affairs, CSRP officially became to a national level society, where the China's Institute for Radiation Protection, CIRP, is its supporting institution. In 2024, it was approved as a member organization of the China Association for Science and Technology, the top level of the academic organization in China. So this slide shows the structures of the CSRP. It includes 195 organizational members and 17 branches, one of which is the Young's Committee. The Young's Committee of CSRP was established in 2019, 5 years as one term, and is now in its 2nd term. It includes 85 members from different units, including research institutes, universities, nuclear power plants, hospitals, and government regulatory bodies. The Young's Committee's aim is promoting the professional growth as well as the international exchange and cooperation of young radiation protection professionals. So second, I will share some good practice in getting more young people involved into RP roles in China. The most successful experience is a competition called the Nuclear Plus X activity, which is mainly focused on the college students. The nationwide competition is held across Chinese universities every year. Its purpose is to encourage more college students to conduct some good products to guide the public to understand the nuclear technology correctly and easily. The type of the products is various, including video, presentations, stories, and so on. At present, this activity has successfully been held for 9 times. Last year, over 80 universities and 12 provincial societies participate this activity. Nearly 20,000 participants and over 4,000 science works, which reach more than 2 million people. This activity has been highly recognized by the China Atomic Energy Agency and the National Nuclear Safety Administration. We turned our achievements of this activity into popular science books and bring them into schools. Second is the university academic activity for master's and PhD students, which has been held for 3 times. This activity is an international academic exchange activities organized by the Young's Committee, which provides a platform for master's and PhD students to showcase their research, achieve collaboration between institutions and universities. Third is the X Plus Young's Forum activity. This activity is mainly for people who worked for the first 10 years. CSRP has established 17 professional branches. The Young's Committee is the only branch established based on age, not rather than professional directions. Therefore, we hold a cross-Young's forum between the Young's Committee and the other professional branches. The activity has been held for 4 times. Another activity is Stories of the Older Generation, which is held every 2 years. The aim of this activity is to encourage young scientists and help them to develop a strong professional outlook and personal values by sharing valuable experience and inspiring stories of the older generation. This year, we will hold the 4th Stories of the Older Generation activity. 5th is the RP Young Scientists Lecture Hall activity. At first, we select CIRP as an example. Every year, over 20 young scientists are invited to come to CIRP to give a high-level lecture so as to promote academic exchange and research collaboration. We recently set up a mentor program to provide young scientists with guidance on academic and career development. By establishing a mentor-mentee system, this program helps young scientists improve their scientific skills and professional qualities. Also, the Young Talent Support Project is established for radiation protection professionals under the age of 32. Each project will support the young talent for 450,000 RMB in 3 years. The aim of this project is to cultivate a new generation of outstanding young scientists. We also have an award for young professionals who are under 45 years old. It was established in 2019 and renamed the Pan Ziqiang Young Scientist Award in 2022 to honor Professor Pan. He was a founding figure in radiation protection field in China, and he was also a former member of the ICRP Main Commission. This award recognized young scientific talents with outstanding achievements and contributions. So finally, I will give a summary. Extensive communication is very important. Only through constant interaction with diverse individuals and young people truly learn new things. We must address different stages of young's development, sparking interest among university students, offering guidance for newcomers to this field, and providing resources to support excellent young professionals. Different ways can effectively meet this goal. The development of radiation protection depends on the young generations. The CSRP will continue to provide them with more resources and support. That's what drives progress of the radiation protection in China. So thank you very much for your attention. That's all my content.
Thank you very much, Hua. It has been a real pleasure to hear you touched, in my opinion, several very important points that are also reflected in many of the questions that we are currently receiving. I really thank all the participants because we are writing several questions that will be feed for the Q&A session. In particular, you were talking about mentorships and the establishment of young generation sector groups within every organizations. And I think that these are two key points to foster, to feed another generation of young radiological protection professionals, and also to link the education and training, the university with the professional world. That is something that many times is missing. Let's go to the next speaker, that is Hielke Freerk Boersma. Thank you very much for being here. Hielke Freerk is the head at the Groningen Academy of Radiation Protection at the University of Groningen. He serves his institute as the coordinating RPE since 1997. So he has a very long experience in radiological protection. That's why we are very, very happy to have you here. So Hielke, please, the floor is yours.
Thank you very much, Lorenzo, and also my thanks to ICRP for offering us the opportunity to tell a little bit about the European Foundation for Training and Education in Radiation Protection. I won't spend too much time in introducing EUTERP itself. We are a foundation containing many stakeholders that are in some way or another active in education and training in radiation protection. Like regulatory bodies, like research institutes, like companies, education and training providers, of course, and also professional bodies. We have currently about 25 associates, and you see all their logos in this slide. But let me move on to the next slide and give you a very short summary of our core aims. And the first three I more or less combined because they are closely linked. What we intend to achieve is a common understanding of the role of I would say not only the RPE, the radiation protection expert, but also the radiation protection officer. Yesterday, there was some discussion on the difference between radiation protection and radiation safety. For me, that is more or less the same, but I know there might be regional differences. We intend to have consistent training and education requirements for both RPEs and RPOs. And we do realize that, for example, education requirements might differ a lot between countries, but we want in the end that there are, let's say, at least consistent training requirements for these experts and officers, because mutual recognition, and I will come back to that 1 or 2 times more in my presentation, is considered to be very important, or at least to agree on the competences of radiation protection experts and radiation protection officers. So that's really our core aim. What we also want to do is, of course, to liaise with our stakeholders, and that is already reflected in the number of associates that we have. But we also want to liaise, of course, with the international organizations like ICRP, like EUTERP, like the agency, and so on and so forth. And finally, and that's of course the most let's say, a common thing to expect from a foundation like EUTERP, we want to achieve appropriate training for radiation protection experts, radiation protection officers, and also for radiation workers. It's good, I think, to make clear that we do not only focus on Europe, although it's the foundation itself is based in Europe, and it emerged from a European project in 2007, was established in 2010, but we try to enlarge our activities beyond Europe. So what are our current and what I would say continuing activities, the most important ones? The first is that we are and were a partner in various EU projects. The most recent one is a project on the review and implementation of the provisions of the European Basic Safety Standards for radiation protection expert officer and for medical physics experts. This is a project that just ended in December, and I expect the report to be published within a few months from now. We also organize workshops, and we have done so since 2007, roughly every 2 years on various topics related to education and training. So far, we had 9 workshops, the last one being held in Groningen in 2023. And we also try to be a focal point for information on training events, on education and training systems in national states through the so-called national contact points. If you want to know anything about, for example, the education and training system in my country, you look up at a website who's the national contact point. You will find my name, by the way, and then I can either give you the right answer, or I can transfer you to, for example, a responsible person within the regulatory body who can answer your questions. And finally, of course, we are doing quite a lot on networking and liaising activities, for example, with the heads of the regulatory bodies within Europe, but also with EUTERP, with the agency, with the ICRP, and so on and so forth. And we are also the co-organizer in EUTERP conferences. These are international conferences on education and training and radiation protection. And actually, we are currently discussing whether we should take over these conferences or not. So the question now is, why are EUTERP's aims important to the future of radiation protection? And I would just mention 2 things. The first thing, and I already mentioned it before, is the fact that mutual recognition of qualifications and competences is of utmost importance. First of all, because it contributes to solving the loss of human resources in radiation protection. We don't have the luxury of having radiation protection professionals available, for example, in Canada, whereas they don't have them in the US. And that links more or less to the presentation that was given earlier this afternoon. We don't have this luxury, so we should use the human resources that are available on a global scale. But it makes also the radiation protection much more attractive for the new generation, because, for example, if you got your degree in, let's say, Finland, and you can easily move to, for example, Portugal, then of course it makes your profession much more attractive than if you are only stuck to your own country. And of course, I do realize that language problems are important, specifically between, for example, Finland and Portugal. But I think that is something that should be discussed. And at the same time, I also recognize the fact that you need to know a little bit more details on national legislation, but I think these problems can be overcome. That's, of course, one thing that we think that is important for the future of radiation protection, and the other one is quite logical. Of course, we strive for high-quality training programs that take into account new technologies. They are the basis for good radiation protection practice, and of course, new technologies have, at least in the past, maybe 10 to 15 years, enabled access to programs on education and training on a much larger scale than before. And I only have to remind you of the developments in, for example, online training during and after the pandemic to illustrate this. And here, I also would like to give what I could say is EUTERP's answer to the Vancouver call for action, because we organized together with the Italian Association for Radiation Protection, so in fact with an ERPA associate society, a train-the-trainer event in the end of June in Milan, Italy, on the use of new technologies in education and training. So focusing on, for example, virtual reality, augmented reality, artificial intelligence, and so on. And we are very happy that the Polytechnical University of Milan is hosting this event. If you want to know more about it, just click on the QR code, and I will show that once more on my last slide, or visit our website, euterp.eu, and link to the upcoming events. When I was invited to give this presentation, we also got a question, what is missing in the current system? And I changed this question a little to what could be improved. And the first thing is, of course, quite logical, because I have been talking about it in the past slides already. I think that ICRP, together with EUTERP, should promote national and regional provisions for the mutual recognitions of radiation protection experts and officers. But I also think that a structured way of performing an impact analysis of new ICRP recommendations, addressing, for example, legislation, addressing operational radiation protection, and as a consequence also the consequences for education and training programs in radiation protection, would be very helpful. At the same time, I realize that ICRP has done an enormous amount of work in the past 10 to 20 years in stakeholder engagement. So it's not a question of that there's nothing in place. I think it's just a way that we might eventually improve. At the same time, I also recognize that this requires intensive cooperation. That's basically what has already been said by other speakers as well. And this also brings me to my last few slides, because it's more or less the position of EUTERP on the question that ICRP has asked us, to what extent the system of radiological protection should align with the UN Sustainable Development Goals. And we have been discussing this within EUTERP already, and we will do so that in our next board meeting as well. But my first impression is that if you look at the Sustainable Development Goals themselves, I think that number 4, more modern and high quality education and training, really is a prerequisite for the safe use of ionizing radiation. If you don't have adequate education and training, then you are it's virtually impossible to achieve all other Sustainable Development Goals. Having said that, of course, promoting health is the main objective of the use of ionizing radiation. That is Sustainable Development Goal 3, but it's also promoting health for let's say the workers as well as for the members of the public by radiation protection. So if we have a declining workforce, and that is of course what has been observed, then the need for mutual recognition of qualifications and competences is of course a quite logical consequence of that. I also indicated in my previous slide that cooperation with liaised organizations is essential, and this matches with the Sustainable Development Goal 17. And I think that these 3 Sustainable Development Goals in fact reflect a system that would in the end lead to achieving most of these Sustainable Development Goals. So it's not it's not something that we need to exactly align with, but if I would summarize the way that we should align with Sustainable Development Goals, it would be something like this. These 3 Sustainable Development Goals are at stake, and if we achieve them, we will achieve most of the other Sustainable Development Goals as well. And with that, I would like to thank you for your attention. And I would also like to thank my co-authors, Jan Vaalbroek, the president of EUTERP, as well as Tom Karijs, who is also a board member of EUTERP. Thank you very much.
Thank you very much. Thank you very much for your presentation. The role of EUTERP in education and training and all the other things that you deal with is so important in Europe. So for us, it is really important to have you here. Thank you very much for your presentation that is full of very important insights. In particularly, I do agree that we have to work pretty much in Europe about the transnational mobility of radiological protection professionals. I have been involved in medical physics expert programs as well. We have faced the same problem, and for sure we have to make Europe less a sum of national categories and more a unique country also from this point of view. We have to remove barriers where it is possible, and this is something that I really thank EUTERP for dealing with. So thank you, really thank you very much. Okay, we are practically on time, so fantastic. We can go to the second part of the webinar that we have heard about what is being done today. Now we are going to listen from what needs to change, so to create a sustainable talent pipeline. And it is a real pleasure for me to introduce Professor Pete Bryant. Pete is the CEO of World Nuclear Transport Institute and professor at University of Liverpool in Radiation Protection Sciences. He is very active in ICRP since many times ago. So it is a real pleasure for us to have you here. Thank you very much, Pete. And please, the floor is yours.
Thank you, Lorenzo. Let me just share my screen. So give me 2 seconds to put into presenter mode. Perfect. So hopefully you can all see my screen. If not, just jump in at any point. So first of all, I'd like to thank ICRP for inviting me to speak at the panel. What I'm hoping to do today is provide a bit of a reflection, in particular, based on my 13 years working in new nuclear build, where I was leading the environmental consenting part, but also radiation protection, and ended up doing a huge amount of stakeholder engagement, and also working on skills development within that. But also I was going to reflect on my time as a former president of the Society for Radiation Protection in the UK, and how this all kind of pulls together into what I kind of think are some of the key things we need to address. So as you've already heard from the other panelists, there's some really great work already going on in tackling the skills requirement. And along with that, they've already provided some suggestions around the need for greater collaboration and communication. So what I'd like to do in my talk is to break this down into 2 key parts. Firstly, I just want to try and emphasize and give everyone an appreciation for the potential scale of the skills challenge. And then secondly, I want to go through a systematic approach of what we really need to do to tackle the skills gap going forward. So firstly, obviously, or hopefully you'll recognize it's a wonderful map of the world. Now, as we all know, that radiation protection is a very vast field. It crosses multiple sectors, from healthcare to industry and the nuclear industry. Each of these sectors and industries continues to grow. It just continues to grow bigger and bigger. And all of this is heightening that concern of skills gap, not only in nuclear, but not only in radiation protection, but in various other areas as well. Now, if we look at just the nuclear sector for a moment, we know that at COP28, there was a wonderful pledge that was launched, and that was the Net Zero Nuclear Industry Pledge, which committed to a goal of at least tripling nuclear capacity by 2050. Now, that was signed by 25 different countries. So what does that broadly mean in terms of just in this one sector, the skills impact? Well, to triple nuclear capacity by 2050, you actually need to replace 450 nuclear reactors and build 1,000 more. Now, that's assuming we're using big reactors. If we start using more and more SMRs, that number keeps on getting bigger and bigger. So if you're anything like me, you would have seen that kind of figures and go, that's a challenge. That's going to be a challenge. Now, to achieve this goal, we are going to need radiation protection practitioners. That's an obvious point. And they're going to be needed first and foremost to ensure radiation protection in these plants during design, construction, operation, and decommissioning. So what's the kind of workforce requirement you would need to meet that? Well, if we look at the workforce demand just in a couple of countries to start, just to give us an indication, what we know that is in the UK government's Nuclear Skills Task Force identified 80,000 new jobs would be needed to meet its new nuclear ambitions. And that was across 4 critical skill areas in particular: project management, welding, nuclear safety, and radiation protection. Now, I think that's a vast underestimate, because the project I formerly worked for, one of the areas I looked at was skills, and we estimated 70,000 jobs just for that one power station. So 80,000 to deliver many, many more stations doesn't sound like, it sounds like there might be a bit of an underestimate in there. But either way, it's a shockingly large number to take away from it. Meanwhile, if you look at France, they estimated, or the French Nuclear Industry Association estimated for its match program, 25% growth in the volume of work by 2033, and that would need at least 60,000 full-time new recruitments to achieve that scope, around 10,000 a year, with at peak 30,000 in 1 year being needed alone. So these are alarmingly big numbers. So it probably should show you the scale of the challenges we're facing here. So these countries alone kind of give you that evidence, and hopefully you can take away a point that the skills gap just in nuclear and RP is very large. Across other sectors, it's going to be even larger, because it's not just nuclear, it's growing, medical's growing, and other parts as well. So how do we start to tackle this challenge? Well, on your screen, you should see a typical career path of a radiation protection professional. This is my very simplistic attempt at drawing what a career path for a radiation protection professional would look like. So at some point, you start education, you make a decision whether to go into further education or vocational training, and at some point, you'll enter a career. And in some places, some people might find that they don't like their initial career, so they might change their career and enter into a career via a different route. So they might choose RP, for instance, later in life. Now, if we look at those broad kind of career journey, then actually what you end up doing is breaking it down into 3 chunks, or 3 core aims we need to start addressing. The first objective is we need to start encouraging students and children at a very, very young age to start taking some of those fundamental background knowledge subjects. So encouraging them into the science, technology, engineering, and mathematics subjects. You then need to, at some point in the further education to starting a professional career point, encourage people into careers in radiation protection or its allied fields, because we often assume that radiation protection skills are just those group of people we call radiation protection practitioners. But they can be a broad range of people, which could be people working in radioactive waste, people working in nuclear safety, people working in nuclear security. It's a really broad range of people who fall under that. And the last part is all around professional development and, importantly, retention. So what we used to find in the UK is even when you could get people into radiation protection careers, they don't stay in those careers. They go off and they seek other careers because they might be greater opportunities to progress. Now, it's a given that within this, we need to target a range of educational routes, including vocational training, such as apprenticeships, alongside those traditional educational routes, such as degree programs, postgraduate studies, PhDs, whilst also ensuring the funding is available to deliver those programs. That's just a given. We've said it before, many people have said it. That's going to be a key part of this as well. But if we start to look at each of these objectives a little further into detail, and using the UK as a bit of a case study, I want to just talk briefly about what we're doing, but what we're not doing, and so what we need to start looking at. So the first objective, as I said, encouraging people into science, technology, engineering, and mathematics. Now, just to be clear, much like we've heard from the previous examples, various employers and organizations like the Society for Radiation Protection in the UK and like other societies that have been mentioned before are doing a great job at running active outreach programs. So as an example, that photo there was taken at the Birmingham Big Bang Fair, which is a massive science event that happens in the UK every year. About 80,000 students go to it every year. So the Society for Radiation Protection, much like various radiation protection employers, whether they're regulators or the nuclear industry or others, they all come to this fair and they do lots of events to try and encourage students into into the field of radiation protection. And that's really, really great. Similarly, some other events run, and things like Society of Radiation Protection at every conference now runs its Science of Superhero events. And this is where we have some hired actors to help us do some great demonstrations on radiation physics. We make it fun, we link it to superpowers. We have lots of actors who are doing gymnastics and stunts to really try and engage students all at the age of 12 and below, which is just to try and pique their interest. However, there is a challenge here. So this is all good. This is absolutely, I'm not saying this isn't really good work, but in reality, we're only targeting a very small portion of potential students. 100,000 sounds like a lot, but it's really not in the broad scheme of what you're trying to do. You actually are only targeting a very small percentage, and in particular, you're also only targeting those that are potentially from affluent areas. And what do I mean by that? Well, ultimately, the people who go to these types of fairs and events can afford to go to these types of fairs and events. What you're not targeting is those harder to reach communities, or those communities that might not be able to afford it, for instance. And this is something we learned very quickly in terms of building our new nuclear build programs previously. So when we started to look at producing education programs or doing skills outreach, we did it on mass scale. We were visiting every school in a region, etc., trying to do it. And what quickly came back from head teachers at those schools was outreach is actually incredibly disruptive at times in terms of schools, because you can help encourage students into careers. But if those schools don't even have the right science teachers to help them reach that ambition, how are we actually helping them get there? So there is a massive point here about going, how do we reach these underrepresented communities? How do we also make sure we're not being disruptive, but we're giving the means to help getting people into those careers and ambitions? In addition, as I mentioned, Birmingham Big Bang, probably about 5 or 6 different radiation protection employers go to that, and professional bodies. We all target the same national event. We all pull all of our resource into one national event. Could we do things better? Could we coordinate between us? Could we start removing logos of who the company is and actually just trying to tackle a real core issue, which is we want to encourage people into radiation protection and target a multitude of events rather than just 1 or 2. In relation to aim 2, the encourage into careers in radiation protection or the allied fields, I actually think this is probably where we're weakest. So how do we make RP, radiation protection, a more sexy job? And what do I mean by that? If you look at, companies that hire people, for instance, in AI, in social media, in programming, why do people want to be TikTokers, for instance? That all appears because it has some kind of great PR around it. It feels like a sexy career to go into. How do we make that same thing work for RP? Now, I know that a lot of people are doing great work visiting careers fairs or writing articles in certain books. So this is a great example of an article that was written by the Society of Radiation Protection in a careers magazine. And that photo in the middle is an example of a job fair that we ran at Sizewell C. Lots of people interested on it. And that's a good start. That's something we're doing to do it. But we're definitely not appealing to the masses. We're not appealing to the larger audience. And we need to do something about that. But importantly, I also heard various people state earlier, and we've seen some questions around, is a lot of this around perception of risk. And I'm going to challenge the panel and the audience on this. So when we started building new nuclear in the UK, we assumed that perception of risk existed everywhere. And so we started talking about radiation protection all the time. Rather than giving reassurance, all that did was create greater fear. Because if you try and tell people, well, don't worry, it's safe, we're doing all these things about it, psychology will tell you, people going, why are they telling me this? Is it unsafe? And so it can actually have a reverse effect to it. So you do really need to think about, what is the message? What does work to attract people into careers is linking it to their core values. So what do I mean by that? Ultimately, people have personal beliefs and values. And if you can sell a career which has a connection to those values, then ultimately you attract people towards those careers. What we found in recent years is very early on when we started the new nuclear projects, we really struggled with recruitment, especially at the graduate side, to get people into the nuclear industry. What we're now finding is over the last few years, due to the increasing emphasis on climate change and actually the new generation being much, much more focused around things like sustainability and green skills, that for certain careers in the nuclear sector, we are bombarded with job applications. So if I look at the time when I set up the environment team in in Sizewell C started with just myself. The second that climate change really became high on the agenda and that green skills really became important, I started receiving 100 job applications for a single job and more. And these are for graduate entry-level jobs. So the second you find a connection, something which aligns with their values and needs, that can make a massive difference. And that's what we need to be thinking about from a PR and comms perspective. And lastly, I'd just like to say, this is a great example of PR. So when I did a Google online about weird and wonderful job adverts that have existed that have actually become viral and actually attract a lot of people, this was one of the examples that came up. Now, I'm not proposing we use that strapline, but it does talk to you an important piece around what grabs people's attentions and actually starts to get them thinking about something or even clicking on a link to understand more about something. So lastly, aim 3. And as I said before, there's some great examples even under previous presentations given around professional development and retention opportunities that are being done. And this has been done by various organizations, associations, employers, and universities. But what's the real challenge here? Ultimately, it comes down to working in silos. So there is a need to pull resources and ensure that practical skills are delivered in any training programs, and that adequate funding is in place to keep all these training programs afloat and support individuals. But what we end up doing is we work in isolation. Now, there are some initiatives that try and pull things together. A great example, the EUTERP Young Generation Network tried to connect all of the YGNs or rising generation groups across the world to share learning about how they attract younger professionals into RP. It's a great example of one. What we tend to find in terms of employers is an employer will develop its own training program and it will use it just for its own personal needs. Or universities might partner with an employer just particular around that area. They'll set up a university educational program. It will work for a couple of years as you have a hiatus and a big peak on people you need to train up. And then those programs just die. That's not unique to RP. We see it all the time. And that's why if you don't have a coordinated approach to delivering skills, then ultimately the programs don't survive. And this is another great example. So this is a photo from my time at Sizewell C. And this is where we did some work on coordinating educational programs. So what we quickly realized is if you leave academic institutions and other organizations to their own right, what happens is you get a very uncoordinated approach. So let's take, for instance, something like environmental sciences. What happens is everyone jumps on the bandwagon to try and run those courses. There aren't enough students to do it all, but then there's loads of other areas we're not developing skills in. So what we tried to do at Sizewell and in the predecessor project Hinkley Point C was actually to give some coordination to this and say, let's get a load of universities together, let's get a lot of regions of the countries together, and also bring in other employers. And also in this photo, it's the mayor of Liverpool into this, trying to bring in other businesses as well, and say, let's set up centers of excellence. And so let's say radiation protection might be dealt with and delivered from Liverpool in the UK. Welding might be delivered by somewhere in Bridgewater College in the southwest. We might say that some of the environmental schools of radiography could be delivered from the southeast. But you actually create centers and you don't compete with each other and you start to coordinate and make sure you're achieving all the key goals in that. And as I said before, another area we just need to really focus on is how do we sell RP as a longer term career, as something that people can stay in, progress in, they can see it as that career path. And that's something we definitely need to do work on. So what I'll end on is just a couple of concluding thoughts. So I've said it before, lots of good work happening, but it's fair to say there's a lot more to be done, especially if we look at the scale of a challenge we need to face. As a RP profession, we have a lot of work to do in PR and comms. And we need to start embracing new and innovative ways of communicating, targeting those audience, such as use of social media, and thinking carefully, what do we want to communicate about? So linking it again back to the values. We do need to start breaking down barriers. We need to stop competing with each other. Employers will compete to make sure they get the best workforce. We need to break down those silos, break down those barriers, start working together. And ultimately, by doing that, start pulling our resources together and efforts together and coordinate. So we can say one party does one thing, another party does another thing. Let's try and do this collectively together, making best use of those limited resources that we have. So let's start getting employers, professional societies, international organizations, education outreach providers, and pulling over funding resources to really do that. And within that, we should also be looking at how do we target those underrepresented communities I mentioned before, and those underrepresented demographics. And that might also include reskilling workforces. So looking at things like as fossil fuels and other technologies phase out, how do we show those individuals they have a longer term career, and it could be radiation protection. But as we do that, we need to also be very carefully to consider what the future skill set is required by radiation protection professionals. So much like the next revision of the system of protection, technologies are developing. Applications of things for radiation, which will require the use of radioactive materials, are changing. And so what we do need to be thinking is, what is the future over the next 40 years? And therefore, what are the types of skills we're going to need RP professionals of the future to need going forward, which might be very different to what we are talking about today. So that could consider things like sustainability, climate change, biodiversity, integrity, other skill areas that might become very important. And with that, I'll just leave you with one concluding remark. So standing here today, virtually, alongside my fellow panel members and everyone dialed into this, I think there's a real opportunity here. And that opportunity is for us to build upon ICRP's Vancouver Core Fraction, and to actually make a commitment today to actually start working together. Just start working together, coordinate our activities together, don't work in silos, and just pull our resources and efforts. And with that, thank you for listening, and I'll pass back over to Lorenzo.
Thank you very much, Peter. Well, I think that in your presentation, you have provided several insights and probably also several answers to many of the questions that we have already received in the Q&A sector of the chat. So really, thank you very much. And I really take your message. We have to work together. This is something I really share. We should do it, stopping and reducing competition in general, but it is especially important where we are experiencing a so important crisis. We are facing a very big challenge. You have shown very big numbers. We have to climb a very high mountain, and doing this alone or competing is something that is completely crazy. So I really share your opinion. In this crisis, there is an embryo, there is a possibility. And probably the most important possibility is the one that you have so well underlined, that we can start working together to shape a future that we share, that we believe in. This is probably the most important possibility that we can also pass to the next generation of radiological protection professionals. And so really, thank you very much, Pete. Okay, now we can go to the last speaker of this day. That is Julie Burtt. Julie is a nuclear regulator by day and a PhD student by night. Her day job as a radiation and health services specialist for the Canadian Safety Commission focuses on the health impacts from radiation exposure. She is also a member of ICRP Committee 4 and supports several task groups. So she has a very long experience in radiological protection. So Julie, please, the floor is yours. Thank you very much for being here.
Thank you so much, Lorenzo, for that kind introduction. Here we are. Okay, so I'm going to build on Pete's wonderful talk and double down on some of his great ideas and insights. And I hope, as you can see from the title of my slide deck, that I want you to walk away from here excited to try something new, try something that you've never done before, speak to a group of people that you've never spoken to before. And so if you've never met me, hi, I'm Julie from Canada. I grew up in Northern Ontario. It was a mining town, or it is a mining town with nickel and copper. You can see the beautiful rocky landscape on the photo here. And I had no idea what I was going to do when I grew up. Still kind of don't. And I didn't know that my future was going to include a mining industry, although be it a different element. So I just wanted to touch base that I credit my high school science teachers for my love of science, and that kind of drifted me off into undergrad degree in biochemistry at Ottawa U. And straight out of undergrad, I started working for the Canadian Nuclear Regulator. And I had a really wonderful director at the time who believed in ongoing education. And so I took some courses that turned into a Master of Chemical Sciences while working full-time. I had the opportunity to do an interchange with the lovely Dr. Ruth Wilkins at Health Canada in her biodosimetry lab. And that kind of kept the continuing education train rolling. Today, I'm a PhD student in interdisciplinary studies at Lorenzo, which makes things busy with being a daughter, sister, wife, and mother of these two adorable children that you see on the screen that will come back later in the presentation. And so, as mentioned, I work for the Canadian Nuclear Safety Commission. Our mandate is to regulate the use of nuclear energy materials to protect health, safety, and security in the environment, but also to implement Canada's international commitments on the peaceful use of nuclear energy. And while those are very important pillars to our mandate, I'm going to focus in on this last pillar, this disseminate objective, scientific, technical, and regulatory information to the public. We're going to go through different ways to do that and what that entails in my day job. And so one way to reach a really wide audience is online. We have hundreds of people tuning in today. This is amazing. And CNSC has a really incredible social media team. So I encourage you to follow their socials. But very specifically, I have a very nerdy, I wouldn't call it sexy, but very nerdy, very effective YouTube video on what is radiation. And there's a bunch of other videos and neat things on CNSC's YouTube channel and different socials. And then aside from social media, like this webinar today, online engagement has really evolved since the pandemic. That was a tough time, but it's brought us to this great evolution of Zoom. And I don't have to be in every single town physically. I can visit classrooms across Canada. And this is actually me giving a lecture to a high school science class during the pandemic. And what I'm going to say is that there are ways to teach online that you would not necessarily do in person, and vice versa. So you really have to find out what works for you. And sometimes sending things in advance, questions or activities, YouTube video links to watch in advance really helps. Encouraging chat. So maybe people don't want to unmute and don't want to put their camera on, but they might want to engage. So different things like Slido, if you've ever heard of that, or like different Tableau whiteboard type of applications to try to get the interaction that you're looking for can also be really helpful for online engagement. But I'll say that the thing that works best is probably having a cameo by your dog. That really gets people excited and engaged and responsive. So moving away from online and to in-person engagement, there are people, I've been reading the chat, people from so many different countries here today, and that's so encouraging. And I'm sure your country has different titles for their different activities. You just have to find out what they are. So in Canada, at the community level, we have things like Cubs or Scouts, guides, used to be called Girl Guides, and they actually hand out science badges. And I have one. I should have brought it here. They're really neat. And if you have a scientist come in and give a presentation or do a demonstration or activity, the Scouts and the Guides can earn their science badge. The CNSC supports staff going to different museum events. So two of my favorites are Cool Science Saturdays and Science Odyssey Fun Fest. We heard from Pete, there was a very large event in the UK. So in Canada, there's a picture here of some experts. These are with my adorable children, so I'm not putting up pictures of other people's kids. And on this day, we spoke to 300 children in Ottawa. So it was a really great event to have conversations. We have a whole demonstration with household radioactive items, Geiger counters. The kids are measuring themselves, their iPhones, the uranium glass products we found in an antique shop. It's a really great, fun way to engage kids and get them excited and make something that's very invisible, visible and real. There are other things that the CNSC participates in, like Let's Talk Science. It's a charity that does like a elementary school challenge day, very game show-esque. And like, when's the last time you were a judge at a science fair? These things are going on in your community, and you can participate. You just have to find them. And then moving into a school setting. I know a lot of you are part of the whole university guest lecture circuit. And Pete had mentioned a few things about elementary schools and high schools. The CNSC we regulate across Canada because we're federal, and we have staff and facilities across the country. So if we're going to travel for work and we have to do a community event or a licensing event, or there's an inspection in a different province, I've actually cold called principals and said, hi, I'm in town. Would you like me to come to your school? I can bring a whole demonstration. We could have an assembly in the gym. And as much as that is disruptive, it has been very well received. Sometimes there's a polite no thank you, but most of the time it goes off really, really well, and it's really fun to do. And pictured on this slide is actually a very recent professional development day for science teachers, where we gave a workshop and we taught different things, and we spoke about how we speak to kids about radiation, how we speak to kids about nuclear safety, and sometimes we dress children up in Tyvek suits. Particularly teenagers, they're very intimidating, and it makes them less intimidating if you dress them up in a Tyvek suit, or make them do basically CrossFit, where you take a rope and you make them make a giant non-ionizing radiation wave, and then you make them make the wave much smaller on the ground with the giant rope, and play games with them, or demonstrate half-lives with M&Ms or Smarties. And so here we have some teachers using some shields painted by my wonderful colleague, Dr. Julie Leblanc, with Nerf guns and trying to demonstrate penetration. So just different activities to engage people, get them out of their seats and think science is fun and science is cool. And another thing that the CNSC does very broadly and very well is mentorship. So we do have a formal mentorship program, and pictured here is my mentee, Emily Barber, where we actually got to attend a grade 9 Indigenous girls outreach event together. So very similar to what we brought to the museum, our display, some games. We brought computer screens because the students were older. And we have like this informal and formal relationship where we can talk about life, or we can talk about work or projects. So it's a really great mentorship program. And then a little bit more broadly, the CNSC hires a lot of students. And so we have undergrads who are just doing a 4-month co-op and have probably never heard of the CNSC, but got in like I did as a university student, first looking for a summer job with the federal government, and then fell in love with my job and never left. We have graduate students and PhD students who their supervisors are work at the CNSC. So their project will kind of fill a research gap that's needed for us, or something that's particularly relevant to the Canadian landscape. And then I also had medical students on retainer, few hours per week, where they would screen articles for me for systematic review. So lots of different students giving their all to the CNSC. And so it's our responsibility to give back by like helping them find student paper contests, getting them to those conferences, offering authorship for the work that the meaningful work that they've contributed. So all of that's really important. And if you've never heard of a micromission, this might be unique to the CNSC, but I encourage you to explore this idea in your own country, where you don't have to leave your job, but you can work on a project for a few hours a week. And resulting from one of the micromissions was a staff member came over to our side of the shop and has never looked back. And that's maybe one of the best things that's ever happened to me, is have someone enjoy working with me, get inspired, and want to switch career paths. So that was like Pete's little graphic coming in at a different point. And then another thing that we've done is conference side events. So the Canadian Radiation Protection Association held a conference in Ottawa, I think it was 2019. And so there's all the technical part of the conference, but the side event was busing in a more remote community into downtown, attend the conference. All the experts were there. We put on a demonstration, fun games with the children, offered lunch, and kind of hopefully inspired them that science is fun and exciting and neat and cool, and there's real jobs and real opportunity there. And so before I wrap up, I've talked a lot about the CNSC and a lot of the best practices that we do and that I hope that you want to try, because I think we're a real leader in this forum. The ICRP mentorship program. I know we heard a lot about it yesterday, and we heard from the amazing mentees. And I've got my amazing mentee featured here, Santa Van Balen, who's a mentee for TG124, the Principle of Justification task group. Like Pete said, I also had, I think it was about 100 applicants for that position. There is a need for more mentors. So I'm calling you to action. Any task group member can be a mentor. If you're on the call today and you're wondering if you're, old enough or experienced enough or enthusiastic enough, reach out to me. I bet that you are. I bet you've got what it takes and that you should be a mentor for your TG. Because the mentees that we have, we heard from them yesterday, they're top notch. They're amazing people. They are the future of RP, and we're in really good hands. I know we need more, but we are in really good hands because like Santa brings her PhD stakeholder engagement perspective and knowledge to our task group. And it's so valuable. And so I know you want to get involved. You're here today. This is you getting involved through I'm sure you saw posts on social media. You're here on the online webinar. We've talked about the mentorship program, but another thing I want to plug is comment on draft publications when they go out for public consultation. That's a great way to learn about the ICRP and what's going on. And so I would like to continue this conversation during the panel discussion, and thank you so much for your attention.
Thank you very much, Julie. It was very interesting, your presentation, because you have shown several examples on how it is possible to engage people at different ages and in different situations. So I think that you have provided several examples on how to engage people. We have several questions about this, so thank you very much. You really anticipated probably many answers. So now I open the panel discussion. So I invite all the speakers, please, to switch on the camera. Thank you so much. Okay, that's great. Let's start with a question for Josip. But if anyone want to add later, please do it. And the question is, with the increasing use of AI, do you think that AI will take over radiation protection, resulting in a further decline of radiation professionals worldwide?
Thanks, Lorenzo. So yeah, I saw this question. I mean, it is a great question. And I personally believe that AI will strengthen the RP profession and not replace it. We are continually looking for ways to make the implementation of radiation safety programs more efficient, and AI just gives radiation protection professionals the tools they need that not only help them complete tasks more efficiently, but if we continue to share information, it'll help us take lessons learned and best practices worldwide and implement it into the work that we're doing. So for example, AI could be used to design a shield for a new hot cell in a nuclear facility, but an RP professional still needs to provide the inputs into the program, review the results, make sure that it meets their needs, and ultimately sign off on its use. And although it may seem that it's taking work away from the RP professional, it's really just making the task faster and allowing us to put our resources towards other work that can't be done currently by AI. And so it would be kind of like saying that, using shielding software as opposed to pen and paper calculations made the RP profession weaker. I would say the software just gave us better tools to use. It didn't necessarily take away the need for an RP professional to use it.
Thank you, Josip. Anyone wants to add something? Well, just a comment. I completely agree. I come from the medical field, and I have experienced several technological advances, and all the time we have the same fear. Probably the computer will replace us, but every time what happens is that we need more people, and we need more skilled, with higher skills people. So because we can do more precise, more faster things, but we need more skilled professional to manage the whole process. So I think that, as Pete showed before, we will have to fill a lot of positions in the coming years, also due to the advance in AI. Thank you, Josip. Okay, there is a question about norm. So the question is, norm effect on the usage of raw natural materials and the residues that are creating in processing. This is the title. In your opinion, what are the breakthrough needed to boost those areas concerning the players involved? Do anyone want to say something? Maybe Peter?
Wonderfully volunteered.
I bring you the hot potato.
So it's a really interesting point, isn't it? I think in reality, yes, norm is becoming, it always has been an increasingly important topic, and it is getting more and more awareness is coming about it. In terms of a question, obviously, it's talking about breakthroughs. I'm assuming this is in the perspective of getting skills and people into the area. So on that logic, I think this all comes back to the same piece. This is all about what's the link with why it should be important to people. Where's that kind of value link? And as long as we can come with that value link, you'll get there. You can, everything, there's various careers. If I look back at some of the challenges we faced in the construction sector as well, trying to attract people into welding. If I look at it as an example, that might be a career that people might go, why would welding ever be an appealing thing for people to do? When we started off looking for training up people who could do high quality nuclear class welds, there was one person in the UK that could do it. One person. We needed hundreds. We had one person. What we ended up doing was going, how on earth could we do this? And we did. We've now met that target. We've got huge amounts of welders now working on one of our construction projects, Hinkley Point C, and it did work. It wasn't easy to get there, but a massive point of it was, how do we sell this as a career to people? And people absolutely love it. If you can find a way it links to them in terms of this means something to their core values. A lot of people love doing physical work, for instance. That's part of how you sell it. It takes time, takes effort, but you've got to think about actually talking to people about what would attract them into it. So don't assume talk to people. Kind of like to Julie's point about actually having the conversations, really, really key. All I'd say is that one individual who knew how to do nuclear welding is now very rich because he had to train up lots of people. So it could be a massive advantage for everyone as well. Think of it that way. So that'd be my view.
Thank you, Pete. Anyone wants to comment on this? Okay. We have another very important comment to me coming from Uganda. So I think this is something that involves all of you, but probably especially Jasminka, because we have a comment that I think refers to equity. As hinted on in the presentation, radiological protection is a neglected field in medicine. Lack of functional policies and regulation, especially in Africa. No sponsor interested in research in that field. Ministry of Health and hospitals have no budget for radiological protection. IAEA is doing its best, but it is a drop in the ocean. So, anyone want to say something about this? This is clearly.
Yeah, I'll add something just because we talked about it the other day about and you mentioned the word like equity and something like, you know, for these events, the reason why we do or have options for people to attend for free is to try to remove those barriers. And I think it speaks to a lot of what everybody's kind of talked about in training and stuff like that. But specifically to kind of Pete's point about breaking down the barriers and kind of doing it together, where it's kind of like it's about us, it's about RP, you know, as a group, as a whole kind of thing. And, you know, those are challenges and not just in RP, about, you know, support in Africa and South America and Southeast Asia and Eastern Europe. And it really is going to take a unified effort of you know, organizations, especially ones that, you know, for, as an example, medical equipment manufacturers or something like we don't, as ICRP, we don't get a lot of support necessarily, but, you know, and there's a lot of advancements in energy and all that other stuff too. And again, I think we need to really kind of take a global look at RP, and that it's not just, you know, Europe, it's not just North America, it's not just Asia, it has to be a combined effort, and there has to be funding coming from other organizations and governments to support what's going on in Africa and otherwise, because there is talented people there. They need opportunity. There's experience there. You know, we need to go find it. And, you know, that's something from an ICRP perspective that we want to have more meetings and more engagement there. But I know Jasminka's got her hand up and Pete as well to comment.
Yes, thank you very much, Kelsey. We have, I see Pete with a hand raised. Please, Pete.
I was going to say, I think Jasminka was first, so I don't know if she wants to go first.
Sorry, Jasmine. I didn't see you.
No worries. As I presented in my presentation, you saw through technical cooperation program, we really support all aspects of even regulatory help to the countries, but also end users. So in this question, for example, was mentioned Ministry of Health and so on. So it is really for years a number of technical cooperation program, even national, even regional, in all regions. So in the Africa, it is also recent Race of Hope initiative by which is provided to those countries equipment in the medical field in order to strengthen capacities. And also, if we're talking about the support to the young scientists, you saw from my slides for Maria Skoldowska-Curie that the highest number actually of participants was from Africa and Asia and Pacific. So we really pay attention on those countries to support in all aspects, even their institutions. I mean, to development regulations, strengthening capacities, but also young scientists through these new initiatives. Thank you.
So I'll just add and build on that a little bit. I think it's a really, really great question. There is no easy answer, in all honesty, because, you know, you look at the fact that it's a very difficult thing. You know, there are so many challenges out there that need to be met, and how do we actually therefore raise radiation protection in that particular area where you're balancing things, other concerns that might be around drinking water supply and others into those parts as well. All I can say is really influence. You know, come back to what Kelsey said. There's two things that need to be done there. Number one, if we do break down those barriers and all pull our resources, we can all have a much bigger pot to help support and influence it. Because we all need to be pushing for radiation protection across the globe, not just in our respective countries or companies or those areas there. So absolutely break down the barriers, start working together, build that resource together. Secondly, you know, you talked about who's the person who can stand up and help, or department who can help bring that representation into Uganda. My answer would actually be, it can be anyone. It could even be you. If you've got the support behind you of a collective group of other people to say they're behind you, they're willing to help, get behind you to help deliver these things. Can be anyone. I remember some very early times I was talking to various parts of Africa around establishing young generation networks for radiation protection. And they said, who could do it? And I always would answer back, why can't it be you? Why can't you start it? We can give you the support to do it. Why can't you be that person to it? So I think a person can be anyone, but what we need to do as a sector is break down those barriers, start coming together and sharing those resources, and actually targeting those areas which are underrepresented in that.
Thank you very much. Thank you both, Jasminka and Pete. Well, another question for everyone who wants to answer or to comment. So this is an open question. If there were no budget constraints, what's one bold initiative your organization would launch to support the next generation of professionals? So if you would have an infinite budget, what would you do? Anyone want to answer?
Shall I make just a kickoff?
Yes, sure.
A very short kickoff. I think that maybe I would just hire one person who could develop ideas about how to engage the younger generation. But of course, money is important, but it is certainly not the only thing. If I would have an unlimited budget, I think that other things would have my priority, like things in healthcare, education, climate issues, energy transfer, and so on. On the other hand, and I would like to come back a little bit to the previous question. I think that if you would send out, for example, young professionals to developing countries, and Pete already gave us, it could be you, and you would have them share their fresh knowledge in the field of radiation protection with, I would say, local radiation protection officers or workers. I think that would help a great lot, because I have the impression that in many small and developing countries, you should start from the bottom up. So raise awareness on radiation protection, educate people, let's say the workforce, and because in general, educational structures they won't be there in the field of radiation protection. If there is only one radiation protection expert in a country, whether it's Uganda or another small, relatively small country, then this is not enough. You need more people. You need a basis for that. And so that would be my appeal. Send the young generation over and make them work it. But on the other hand, we don't have unlimited amount of money. So unfortunately.
Thank you very much. Josip, please.
Yeah, I mean, I could think of so many things, but I think one that's achievable, generally achievable, is just, trying to get the next generation involved in, conferences, presentations, professional committees. Right now, one of the challenges we have is that, it's costly, right? And in general, going to a conference, you can do an online conference, which is great, and you learn a lot, but the real value of the conference comes from that networking you do between meetings, after, in the evening, that kind of stuff, right? And you lose that ability to kind of build that community of radiation safety professionals that don't just know each other through social media, but have actually met each other, have had a chance to get to know one another, have a chance to work together on committees, build relationships, and so on. And so I find that a lot of times we're having a lot of these conferences, and because they're expensive to go to, and and there's travel costs associated, that we don't get a chance to get a lot of that young generation there. And so that's why I very much appreciate the work that ICRP is doing today, right? Try to get money to get more young people to the ICRP meeting coming up, right? I think that's so important, because at the end of the day, I'm going to retire at some point, and the next generation is going to come up, and they need to be involved in the changes that are coming to recommendations. They need to be involved in the working groups. We need to engage them, but that involves helping them with the costs, right? because let's face it, I'm not paying my own costs either. Someone's paying mine, right? So we need to consider, if we want to have young professionals, if we want to engage them, and if we want them to be part of the process, then we need to invest in them early so they can be part of that process. And so if I had more money, I would love to see us engaging more young people to come to these conferences, to take part in these committees, and be part of the solution, the discussion, instead of us just telling them this is how you run a radiation safety program, because they really do have some amazing ideas. I know I'm already talking too long. I'll just say one more thing, is that, I'm very fortunate because I'm at a university, I have access to all this young talent, right? And so right now we have like 14 students that are working in the health physics department, and it is amazing the ideas that they come up with, right? Because I joined RP at a time where we didn't have a lot of this software, and we didn't have AI, and we didn't have these things. So I look at the world in a way that they don't, but they come up with amazing solutions. And so again, if we engage them, it'll be great, not only because we will have, their view and engagement, but they will come up with solutions that people of my generation won't. And so that's why it's important for us to do that. Thanks.
Thank you very much, Josip. Well, we have also a suggestion from the audience, from Dean Crouch, that say unlimited budget ICRP Formula One team. Okay, but we have also Pete with a raised hand. No, sorry,
Kelsey was first.
Yeah.
Sorry.
No, I just wanted to just distract him kind of. I think what Joseph said is it's realistic, and I think that is a logical thing to focus on, and I think that's something that people from all organizations all around the world can probably do something to speak to that in the short term. Now, if I'm thinking with my illogical hat on, in terms of like, if I had all the money in the world, this is something that I know Pete and I have talked about before and stuff. Like, until the day comes that like we can pool enough money together to pay people like Justin Bieber and Cristiano Ronaldo and Selena Gomez and Taylor Swift to go on TikTok and Instagram and pay them to say radiation is cool. This is all the, radiation saves lives, radiation, there's clean drinking water. Until that day comes that we can pool together like the money to do that. I mean, I think that to speak to people when they're 15 years old and get to them, in their younger ages, like that's something that needs to happen, in my opinion, and a concerted effort to have these people highlight and say, because that's how young people are getting their news. That's how they're getting their information, is on TikTok and YouTube shorts and Instagram reels and stuff like that. And we just need to pay Taylor Swift to say RP is cool, and then everything will be fine.
I think, Kelsey, we just learned what type of music you listen to. So I think what I'll just add to that particular point is, if we ever had a pot of money, if I had a large pot of money, or let's just say I had a smaller pot of money, but I had some money, first thing I would do is I'd try and actually have a collaboration center to try and pull this collaboration together, to try and steer people into a consistent direction. So to split up the work, as we said before. And if I had a lot of money, I'd have regional collaboration centers. Now, the reason I'd say regional collaboration centers is because you can't assume that every country is the same, let alone actually even every county or subdivision of a country is the same. There are different challenges, different things need to reach. So how you design your communication would be different for each of those regions. How you design your educational programs would be different for each of those regions as well. So I think that would be my first point. Establish some kind of coordination center to move things forward.
Thank you very much, Pete. Please, Julie.
Thanks. I agree with what everyone has said, and I want to add an idea. Lorenzo had called on the panel members to share their ideas. We're doing a lot of work. Pete highlighted a lot of the speakers highlighted what we're doing. We have no accounting for that work. We have no way to summarize it. We don't know how many people we've reached. And I remember someone had asked me, like, how do you know your YouTube video is good? I was like, well, it's got a lot of hits. That's not evaluation. That doesn't mean it's good. And so if the ICRP could explore evaluation of themselves, account for how many people we're reaching, and look at that. I have some ideas. Stay tuned for the future. We need to kind of audit ourselves and look at what we're doing and who we're reaching and how we're reaching and who are we missing. And so goes to Pete's comment on remote communities and people that we might not be reaching. So more to explore on that in the future is kind of that self-evaluation and where we've been and where we should go. Thanks.
Thank you. Thank you very much. Any other comment? No, I don't see any raised hand. Okay. I read a comment just because, well, I like it very, very much. This participant say thanks to all of you for the excellent presentation and say thank you very much for making this space. And it is really encouraging to know that there are many people concerned about radiological protection and doing their best to let it the place it deserves. So this is, I think, a quality evaluation from Julie's point of view, you know, at least one. But I think this is what we can do, actually. This is something that is very, very important. And again, thanks to the ICRP, because this, in my opinion, this is not something that they have to do. They decided, they took this decision. That's why I really thank all of them, because, and not the ICRP as an abstract entity, but the people, so Werner Room, Chris Clement, Kelsey Cloutier, all the members of the committees, because behind decisions there are people, and they decided to follow this route, to open this door, this possibility to all of us. So really, thank you very much for this. Okay.
I think, Lorenzo, we only have a few minutes left, and we just have a couple.
Yeah, sorry.
No. So maybe just do like, yeah, one more question. Again, so for anybody that, if we didn't get to your question, we will certainly do our best to share these around with the panel in the days to come, and hopefully have some sort of written answer or something like that that we can post on the website afterwards, where the recording will live and everything else kind of from here. I do know there was one good question that I saw, so if you don't mind, Lorenzo, I'm just going to kind of ask if anybody thinks from Megan Cook, and she's from Australia, but is there any way to coordinate support for development of young RP professionals in specific regions? So we touched on it a little bit. Does anybody kind of want to elaborate?
I can jump in a minute. Australia, obviously, you've got your Australian Radiation Protection Society, and I believe they have only very recently established a YGN under them. They're trying to do that. So if you're not a member of that, I definitely encourage you to do that. And if not, you know, there's also other initiatives through EUTERP. So through the International Radiation Protection Association, they have obviously got the international YGN there as well, which is helping to pull things together. But definitely look into ARPS if you haven't already, because they're starting to do some really good work there. So sounds like you're passionate about it. Get involved. It'd be great.
Yeah, thanks, Pete. And you know, again, once the recordings and slides are available, you know, rewatch what Jasminka was talking about with initiatives that are going on at the IAEA. Achim also talked about things going on with Pianoforte and Eurodose, and even though, again, Eurodose is based out of Europe, people from all around the world are eligible to apply for some of their initiatives, and so we definitely suggest that you do that. But yeah, so I guess with that, what we'll do, or what I'll do anyways, is just spend a few minutes. First of all, thank you to all you guys for coming today. This was kind of an idea that was brought up about 1.5 years ago, and just over a year ago. You know, special thanks to Pete and Julie and Achim and Emily, a few that we had the original kind of conversation and thought way back when, and it's crazy how quick time flies to do this. And you know, the feedback so far has been great, and certainly something I think and I hope that we do more of, to have you know, these necessarily, there's a lot of great information, but it's not, you know, numbers, it's not you know, dosimetry and things like that. I think it's important to have more open conversations like this, and more kind of input into that process. So it talks like a lot from Julie's perspective, but a lot of change happens on the local level and on the community level, and that doesn't necessarily mean just going into schools and stuff like that. It's about taking what you've heard these last couple of days and talking to your local societies and your employer about being a part of the team or the team effort that that Pete was talking about from kind of a global perspective. So I think no matter if you're in high school or secondary school or in university or retired, I think there was something over these last 2 days that you can take and do some sort of action tomorrow and do something positive to kind of help some of the challenges that the RP community is facing. So again, it's been mentioned, attend ICRP online workshops. If you're able, come to ICRP 2025. Communicate with us, send us emails, ask us questions. If you have further questions for some of these amazing professionals that have been on the call these last 2 days, email ICRP and we're happy to connect you with them and try to dig a little deeper. So I think the message is communicate and teamwork. Really, like it sounds cliche, but that's really kind of what it's about. And it's not just about ICRP; it's about everyone that has every stakeholder, anybody that has interest and is related to RP. So with that, thank you. Have a wonderful day. And like I said, communicate, teamwork. Thanks, everyone.